Boys and girls, in my today's class, I'm going to solve a creative question on the basis of chapter number 11, current electricity in physics part, and this lecture is applicable for the student of class 10. Boys and girls, a stem of a creative question is given in the board. You see, boys and girls, there is a circuit, and there are 5 resistors here. That is R1, R2, R3, R4, R5 with a battery. And there are 4 questions here, just like a creative question set. Here question number A, what is called resistance? Question number B, why ammeter is connected in series connection with the circuit? Question number C, calculate the total current of the circuit. Question number D, that is, if this circuit is turned on 5 hours in one day and cost per 1 unit electricity is 8 taka, then calculate total electric bill for the month of April. Now I'm going to discuss about question number A. The question was, what is called resistance? So, resistance. Boys and girls, resistance is a special electric property of any circuit, of any electric device, of any substance, which can create obstacles when electricity passing through it, which can create just like a blockade, just like obstacles when electricity wants to pass through any electrical device. So, in the case of definition, I can say that the electric property of any circuit which can create obstacles when electricity passing through it is called resistance. Now, question number B. Question number B, that is, why ammeter is connected in series connection with the circuit. Let's draw a simple circuit. This is a resistance and this ammeter, and this is a battery, electric battery or cell, and this is a switch or key. Now this electromotive force E, this switch or key K, this resistance R, and this ammeter. So this point A, I can say that point A, this point B, and this point is point C. Boys and girls, when I turn on this switch, say boys and girls, this is a switch. When I turn on this switch, then you see that this battery will produce here I amount of current, and this I amount of current passing through the circuit like in this direction. Okay, so this I amount of current passing through the circuit. Now boys and girls, to calculate or to find out the circuit current, here ammeter is used. In short, ammeter is a kind of meter or is a kind of device by which we can find out electrical current in the circuit directly in terms of ampere unit. What? In terms of ampere unit. Now boys and girls, but the main question is here, why ammeter is connected in series connection. The main question is here, why ammeter is connected in series connection. Now I can say that there are 2 reasons here. First of all, characteristics of ammeter. You see boys and girls, first of all, this point number A, first of all, an ammeter, especially an ammeter has a very small internal resistance. I can say that an ammeter has very small internal resistance. So this internal resistance is a very small, so that there is no drop of electricity takes place inside the ammeter. In short, this internal resistance value will be very close to zero. So when electricity passing through the circuit, passing through ammeter, so no electrical drop, no voltage drop takes place inside the ammeter. That's why ammeter is connected in the circuit. And the second point, point number B, that is ammeter gives us electric current in terms of ampere unit. Ampere unit directly. Ampere unit directly, okay? But next question. If I connect this ammeter with the resistance in parallel connection, then let's see what is happening here. So now, boys and girls, when I connect this ammeter with the resistance, this is a battery, and when I connect this ammeter in series parallel connection with the resistance, then let's see what is happening here. Say this is a positive terminal and this is a negative terminal, okay? And when I connect this battery, then I can say that this battery will produce here I amount of current. What? I amount of current. When I amount of current comes to the end of point A, then I see that at point A there are two options, there are two branches here, okay? One is ammeter and second is resistance. Boys and girls, one is ammeter and second point is here resistance. So this ammeter can pass electricity and this resistance can also pass electricity. But resistance has a value to obstacles electricity. So this resistance can able to create some obstacles when electricity passing through it. So this is a rough path. But the internal resistance of ammeter is very small. That's why ammeter is a very small or very smooth path. That's why all of the current I passing through the ammeter and go at the negative terminal of the battery, and no electric current passing through the resistance R. That's why this resistance R remain turned off. I repeat, this resistance R remain turned off. That's why this device is not applicable for practical purpose. So this ammeter cannot be connected in parallel connection with any resistance. That's why these are the two main reasons why ammeter is connected in series connection with the circuit. So the main reason is here, the internal obstacles or resistance of ammeter is very small and this value seems to be very close to zero. Now I'm going to solve question number C. Now boys and girls, I'm going to solve question number C. So question number C. Calculate the total current of the circuit. So before calculating total current, I need to calculate here the total resistance of the circuit. I repeat, I need to calculate here the total resistance of this circuit. You see, boys and girls, at point A, resistance R1 and R2 are the two paths, are the two branch of resistance. So at point A, electric current divides into two paths. That's why R1 and R2 are currently in parallel connection. And then at point C, electric current also divides into two paths. One is R4 and another is R5. That's why I can say that here R4 and R5, these two are also connected in parallel connection. So these are the parallel connection and these are the parallel connection. But whole circuit, that means this part, whole part R3 and this whole part are connected in series connection. So I can say that the equivalent resistance of R1 and R2, it must be, I can say RP1 will equal to 1 divided by 1 by R1 plus 1 by R2. If I put the values of this R1 and R2, 1 by 4 plus 1 by 4. After calculation, the equivalent resistance becomes here 2 ohm. Now, for the case of R4 and R5, here the equivalent resistance RP2 will equal to 1 by R4 plus 1 by R5. Now boys and girls, here also the value of R4 is 4, so 1 by 4 plus here also 1 by 4. So total equivalent resistance will be equal to here also 2 ohm. Now the total resistance of the whole circuit, I repeat, now the total resistance of the whole circuit, okay, so this total resistance R will be equal to RP1 plus RP2 plus here R3. So total resistance becomes here 6 ohm. So total resistance becomes here what? 6 ohm. Now I'm going to calculate the electric current of this circuit, total current of this circuit. So total current of the circuit is here E divided by capital R. Now electromotive force is 6 volt divided by 6 ohm. So totally 1 ampere current passing through the circuit. Boys and girls, totally 1 ampere current passing through the circuit. And now question number D. Question number D is a very long question. You see, if this circuit is turned on 5 hours in one day, I repeat, if this circuit is turned on 5 hours in one day and cost per unit electricity is 8 taka, then calculate electric bill for the month of April. Then calculate electric bill for the month of April. Okay. Now, boys and girls, I need to find out electric bill at question number B. So, question number B. At first, we want to find out the electric work of the circuit. Before find out electric work done, there are some given information here. The first one is electromotive force or voltage is given. At question number C, I already find out the electric current of the circuit. So here I and V is given. That's why the formula of electric work done is V I T. Now, my first point, voltage V or electromotive force E, total part is 6 volt into total current, that is 1 ampere, into, I need to convert this whole time in terms of hour format. This circuit is turned on basically 5 hours in one day. Basically 5 hours in one day. And I need to calculate the whole bill for the month of April, that is 30 days. So this is 5 hours per day, and April is a month of January, February, March. April is 30 days. So 30 in terms of hour, and then boys and girls, you can say that the time is converted into hour, and I need to convert the power. This function V into I is known as electric power. Electric power. So electric power must be converted into kilowatt to find out electric work done in terms of electric bill or electric unit or kilowatt hour. So kilowatt hour. This is V into I gives you watt. This V into I will gives you watt, but I need to convert this watt into kilowatt. So how can I convert this? Dividing 1000 by the whole function. So this function will give you, this function will give you 6 into 5 into 30. I repeat, 6 into 5 into 30 divided by 1000 will equal to 0.9 kilowatt hour. 0.9 kilowatt hour. And you know, boys and girls, 1 kilowatt hour equal to 1 BOT equal to 1 unit. So what's called BOT? BOT means here Board of Trade Unit. BOT means here what? Board of Trade Unit. In short, this is known as unit. So I can say that this kilowatt hour will give you 0.9 unit electricity. It is lost in month of April. In month of April. Now, electric bill. Electric bill. So, electric bill is unit, that means 0.9 unit into cost for 1 unit electricity, that is 8 taka. I repeat, cost for 1 unit electricity, that is 8 taka. So 0.9 here multiplied by 8. So I can say that if 0.9 is multiplied into 8.9 into 8, that is 7.2 taka. 7.2 taka will pay for the month of April. Will pay here for the month of April. Now I can say that if this circuit is turned on 5 hours in one day and cost per unit electricity is 8 taka, then the electrical bill for the month of April is 7.2 taka. I repeat, 7.2 taka. Now boys and girls, I'm going to give you a homework. I'm going to give you a homework similar to this creative question. You can solve this homework at your home. So your homework. Now boys and girls, this is your homework but this question A, B, C, D remains same. You can solve this question on the basis of this given circuit. Boys and girls, you can solve this question A to D, A, B, C, D on the basis of this electric circuit. Thank you very much, boys and girls. Thanks to all.